So this section is equations with rational expressions. So it'll be like how we dealt with equations with fractions back in chapter 1. So you first have to figure out what our common denominator would be for all of these. And our common denominator would be 4x. So you want to go ahead and multiply both sides by 4x. And remember, since we're doing it to both sides, that's okay. So on this left side, we'll have 4x times 2 over x plus 4x times a half equals 4x times 9 over 4x minus 4x times 1 over 2x. And now, notice here on this left side, the x and the x will cancel, and we're left with 8. Right here, this 2 will cancel with this and become a 2. So we're left with 2x equals, on this right side, this whole 4x will cancel with the 4x. We're left with 9 minus the x will cancel with the x, and this 2 will cancel and make that a 2. So minus 2. So now, when we simplify, we'll have 8 plus 2x equals 9 minus 2 is 7. X equals negative a half. And now let's look back up at the beginning. If we look in our denominators, we have to figure out, is there any value that would make any of those 0? Well, if x was 0, we would have 0 in the denominator, which means our x can't be 0, because then we'd be dividing by 0, and we can't do that. First thing we need to figure out is, are there any values that x cannot be? And in our case, x can't be 2, because that would make this denominator 0, and you can't have a 0 in your denominator. Once we take care of that, just like when we had equations with fractions before, if you multiply both sides by your common denominator, it's okay because you're multiplying both sides by the same thing. In our case, our common denominator is going to be 10 times x minus 2. So on the left side, this 5 and this 10 will cancel, and we'll be left with a 2 in our numerator. So we'll have the original 2 times our x minus 2. And then this x minus 2 will cancel with that x minus 2, and we're left with 5 times 10. And on the right side, these 10s will cancel, so we're left with 29 times x minus 2. And now we'll just simplify or solve this like we have been all year. So 4 times x minus 2 plus 50 equals 29x minus 58. And now we have to make sure, was 4 one of the numbers we said x couldn't be? And no, it's not, because x couldn't be 2. So here's our answer. So let's start this one by factoring. And now notice, x can't be 2 or negative 2. So we'll need to keep that in mind. And we're going to go ahead and multiply both sides by x minus 2 and x plus 2. Notice on the left side, since it's multiplying by 1, nothing is going to cancel. So we're left with x minus 2 times x plus 2. Notice in this middle one, this x minus 2 will cancel. So we're left with 3 times the x plus 2. And notice in this second one, both of these will cancel with both of these. So we're left with minus 12. And on this left side now, this is actually what we started with. It's a difference of squares. So we know this is x squared minus 4. You can just distribute it out and you'll get the same thing. Since we have a squared term, this is quadratic, we've got to get everything on the same side. And this will factor. So now let's look at the beginning. We ended with x is 2 or 1. But notice at the beginning, x can't be 2. So that means our solution is x equals 1, but we need to go ahead and state that this x equals 2 was extraneous. Alright, on this one, first off, notice we can factor into x minus 2, x plus 2, and you do always want to start by factoring. And now let's also notice we can't have x be 2 or negative 2. Those are the two options we cannot get for our answer. So when we find a common denominator, it would actually be x minus 2 times x plus 2. So you have to do that to both sides. Notice on the right side, these will cancel with both, so we're just left with 2x squared. On the left, this x plus 2 will cancel with that x plus 2. So we'll have 3 times x minus 2. And then this x minus 2 will cancel with that one. So 2x times x plus 2. And let's go ahead and get all these 2x squareds together. And then let's double check, can that be one of our answers? Well, our x couldn't be 2 or negative 2. This is neither. So we are good. Now on this one, notice x cannot be positive 6 because that was what would make our denominator 0. Our common denominator would be x minus 6. So over here, these will cancel, and we're left with 6. Then we'll have 3 times this x minus 6. These will cancel on the right. We're left with x. Let's check it. Now notice, though, we said x cannot be 6. So that means this won't work, because if we did use that, our denominator would be 0, which we can't have, which means our answer is actually no solution. So first off, when we have a quotient of two numbers, we call that a ratio. And when we have an equation that states that two ratios are equal, it's called a proportion. And to solve these, notice that we could multiply both sides by 5. And now this would cancel out here. But we also want to get rid of this 3, so we can multiply both sides by 3. And then these 3's would cancel. And we're left with 10x equals 3x. Get our x's on the same side. And there we go. On this one, let's start by seeing x can't be 0 or -3 because then our denominators would be 0. So we can't have either of those for solutions. So we're going to cross multiply, which is essentially what we did here. So multiply both sides by x plus 3 and by x. And what happens is on the left side these will cancel, and on the right side these will cancel. And we're left with x plus 3 times x minus 1 equals x times x. And now we just need to distribute. Since we have x squared, set it equal to 0. And now let's check. Our answer is 3 halves. Notice those were not either of the numbers we can't have for our answer. So we are good. On this one, notice we're already stating x can't be -2. So when we cross multiply, on this side we'll be left with 3x plus 1 times x plus 2. And on the right side, we'll be left with x times 12. Distribute. And now we do have a squared term, so we need to get it equal to 0. And this will factor. Neither one of these were what we can't have for our answer, so they both would work. Now, some proportions. If we have 8 large pumpkins and we know they cost $38, we want to know how much will 5 pumpkins cost. So we can set up a proportion here. We know 8 pumpkins is going to cost us $38. Well, the pumpkins are going to be the same cost, so we want to know how much 5 pumpkins will cost what. So we can call that x. Well, now we just have to cross multiply. And I'm going to work on the right side. So we'll have 8x equals 5 times 38, which is 190. When we divide both sides by x, we get $23.75. So at this going rate for the pumpkins, 5 pumpkins will cost us $23.75. Same thing here. We have a map, and maps will always have a scale. It'll say, like, for example, this one, every 2 inches represents 40 miles. So on the map, we have 2 towns, and they're 7 inches apart. I want to know how many miles are actually between the towns if we are going to travel them. So we know our ratio is 2 inches is the same as 40 miles in real life. And so, if we've got 7 inches on the map, that's how many miles? When we cross multiply, we'll have 2x equals 280, or x equals 140 miles. So now, here we've got a flagpole. And we know its shadow is 15 feet. We also have a person who's 5 feet 6 inches, so 5.5 feet tall, and her shadow is 4 feet. We want to know how tall is the flagpole. That means here's our variable. That's what we don't know. And so, we've got the height of our flagpole and its shadow is going to be the same rate as the height of our person with her shadow. So our x is 20.63 feet. Alright, variation. When we have direct variation, it means as something increases, the other something that's paired with it is going to increase. And our formula we're going to use is this A equals KB. One thing to notice, this is going to be our constant of variation. And we're just going to keep using K in this class. So for inverse variation, this would be as something increases, the other decreases. So once again, our K's here are this constant of variation. Notice now, instead of getting multiplied by the other variable, it's getting multiplied by the reciprocal of that variable. Compound variation is when we have more than two variables in the relationship. So we're going to go ahead and go through some examples. We're just going to write these formulas as equations and actually get the variables in there. We're going to still use K as our constant of variation. So this first one, we know B varies directly as something. So B varies directly, so we're going to have our K times something. And it varies with the fifth power of m, or m, to the fifth. And that's all we need. This one, we've got R varies inversely. So R varies inversely. And then it's with D, so this D is down here. We could also have this just K over D, and that's the same thing. Alright, G varies jointly, so that's still directly, so we'll have K times something. The product of A and B, product is multiplication, so A times B. This last one, we'll have Y varies directly with N, so that means Y varies directly with N, but also inversely with P, so that's the 1 over P. Or we could have Y equals, and then K and N both in the numerator, and just P in the denominator. Both of them are okay. Alright, so now we're talking about a couple pipes, and they're filling a pool. So a couple things. We've got pipe 1 that we're dealing with, pipe 2 that we're dealing with, and what they can do together. The rate for pipe 1, it can do one pool in 9 hours. So its rate is 1/9. We are also told that together they can fill one pool in 3 hours. What this means then, the rate for both together is 1/3. Pipe 2, we know it can do one pool, but we have no idea what the rate is or how long it takes it to fill a pool. And in fact, that's what we're asking. So this will be our X hours. Oops. So this rate is 1 over X. Now we know that pipe 1's rate plus pipe 2's rate gives us their rate together. And now this is the types of equations we had at the very beginning of this section. So we can multiply by our common denominator, which would be 9x. On the left side, we'd be left with x plus 9. And on the right side, 3x. So our x is 9 over 2 or 4.5 hours. So that's how long it would take the second pipe to fill the pool. On this one, we are going to be using the formula distance equals rate times time. And we're going to look at leg 1 of the trip and leg 2 of the trip. The first part, she's traveling 120 miles, so that's our distance. We don't know what her rate is, and it's for a certain amount of time. So time 1, subscript 1 is the first time. For the second half of this, we know she goes 210 miles. Her rate is increased by 10 miles an hour, so it's the same rate before plus 10 for however long the second part of this trip is. However, we are told that her total time is 5 hours. So what this means is our time 1 plus our time 2 is 5. So notice that also then means we have to get both of these so that it's t equals something. So let's go ahead and look at this. This first one, to get t1 by itself, we're going to divide both sides by r. And on this one, we're going to have 210 divided by r plus 10 is equal to our second time. Now we can use our formula that's up there in the green. So I'm going to go ahead and rewrite it down here. So our time 1 is this 120 over r, plus our time 2 is this 210 over r plus 10. Notice we have only one variable, so that's what we wanted. Our common denominator would be r times r plus 10. On the left, that first fraction, the r's are going to cancel. And so we are left with r plus 10 times 120. On the second one, the r plus 10s are going to cancel, so we're left with r times 210. And on the right side, we're just going to have 5r times r plus 10. Alright, so now we've got that r is 60 or negative 4. But coming back into our problem, our r was our rate. So we can't have our negative rate of 4. So that means our rate's got to be this 60. So her rate was 60 miles an hour. So this is going to be our variation problem. We know that the value of a computer varies inversely with its age. So its value varies inversely with its age. And I'm going to go ahead and just put time. T, you could use an A, it's the same thing. Alright, so now we are given that a computer worth $400 is 12 months old. So we know this $400 when our t is 12. Well, now to get our constant by itself, our constant of variation, we can multiply both sides by 12 Notice these are going to cancel. We're left with K. 12 times 400 is 4,800. So we can now use this constant to figure out how much it's worth after 20 months. So once again, we're going to start with this equation, but we know our K. Our K is this 4,800. And we want when 20 months old now. And so now we just simplify this and get to 40. So we're going to start by getting our general relationship here. And we are told to use D for drug and W for weight. And it tells us that the amount of drug needed is directly related to the patient's weight. So what that means is the amount of drug is directly related to our person's weight. And then we are also told that somebody that's 180 pounds requires 5 milligrams. So our dosage is 5. We have our constant of proportionality, and our weight was 180. So divide both sides by 180. So now we're going to use this to figure out how much drugs we're going to need for someone that's 234 pounds. So our general formula now is our K is 1 over 36 times the person's weight. And we want to know for someone that's 234 pounds, so if you want, put it over 1. And they'll need 6.5 milligrams, or 6.5 milligrams.